change the color. All right, so AL we have 1, okay, BR. Okay, mass of AL, we're just going to use whole numbers, is 27. BR is 80. Now you can use decimals. I just do this because it's easier on my math on the board. 27, what's that, 240? Yeah. 267? Yeah. All right, so when we want to find the percent aluminum, what goes on top? The mass. Which is? All right, so the mass of the element on top. What goes on the bottom? So the mass of the whole compound on the bottom. And then times 100. To find the percent bromine, what goes on the top? Yep, the mass of the element, so 240. And then over 267, which is the compound, again, times 100. All right, so what'd you get for the answer for aluminum? You got 10%. All right, anybody take it out anymore? So you all rounded to 10? All right, 10.1. Remember, there's no significant digits, so you can use decimals or you can round off. So 90% or what, 89.9%. Either one is fine. Questions about either of those two problems? Okay. For the second one, to solve, how many MNs do we have? How many CRs? And how many O's? Okay. Times the mass of that one, we'll just say 55, 52, 16. So what's that going to be? 110, 520, and what's this one? 560? Add it up, what do you get? You're going to had to be a little louder over there, Diego. What was that? 1190. That can work. All right, so for the percent manganese, what's on top? 110 over times 100. All right, for the percent chromium, what's on top? 520 over 1190 times 100. For the percent oxygen, what's on top? Over what's on the bottom? And then times 100. All right, so what answer did you get for percent manganese? 9.2. All right, for the percent chromium, what'd you get? Okay. And for oxygen, what'd you get? Anybody not okay with finding percent for Thursday? Yep, I'm getting ready to go grab the test, so I just leave it there.
Here we go.
Yep, never mind, I already brought them out.
That's what it says.
Huh? But that's only one question on Thursday.
I want some.
Okay. What?
Oh, it's a test on Thursday?
It's a quiz. Sorry, it's a quiz. We have the lab grade tomorrow.
Are you having a good day?
Okay. Can't complain. How about you?
Oh, fine. Pretty good.
That's good. All right, I need to send out
Me.
Ariana and you. Oh, and while I'm thinking about it for you two, I already told Ariana this.
Adriana.
Adriana. I don't have any days to make this up until next week. Is that okay?
Yeah, okay.
Okay, I'm glad to hear that.
Can I put a phone on this?
Can you what?
Charge my phone.
I'm plugging it up over here behind my desk. questions, things you want to ask? Nope.
We don't got fifth no more.
Nope. The only one that I might consider is the benchmark. Because that will be on multiple choice, but nothing else this quarter will have test corrections. But your major stuck with. I didn't think it was that bad.
What was the class average?
Didn't average it because I don't care.
Well, I'm in
They were all passing in second and third with the exception of one.
What's the percentage for the grade?
Mhm.
Like a little.
Oh, that was only the multiple choice. That was out of 40 points. That was only the first 20 questions. So anything circled on a page is the total for that page. So don't look at it as if it's circled on like question 45, that those are the points for question 45. Because I grade them one page at a time. So I don't know whose paper I'm grading. So anything circled is just the total for that page. Because I go back and then add all 4 pages together. So I don't have any idea whose paper I'm grading when I'm grading.
The grade that you circle on here, that's like our total.
That's your total grade. Yes, that multiple choice grade means absolutely nothing. Some of you did better on the multiple choice. Some of you did better on the first response. Some of y'all sucked at both of them. Now, for the next topic that we're going into, questions 31 to 41 are essential. If you are struggling or you lost a lot of points in questions 31 to 41, you need help. Whether that's with me or a classmate, I don't care who. There are lots of people in either second period or third period who are honor society people, or people from last semester who can still do it, who are in the honor society and need tutoring hours, okay, that I can hook you up with. But you need help if you can't do 31 to 41 before Friday, okay, or you are going to bomb the next unit unmercifully. I can't say that strongly enough. The next unit, other than the 2 things we're doing today, which are stoichiometry, math, we're going to do them today. We're going to do some tie-in tomorrow with the lab. We're going to have to write some names and formulas based on the math we do that's a lab grade tomorrow with a partner. Okay? After that, we're going to chemical imbalance and equations. You're going to have to write the names and formulas and crisscross and balance and predict formulas. For example, by next week, you're going to have nothing more than sodium plus sulfuric acid with an arrow. And you got to turn it into what it belongs in. So you got to change it into Na plus H2SO4 becomes Na2SO4 plus H2. And then you got to turn around and go, oh, what doesn't balance? I need a 2 here. Okay? You have to do all that on your own by middle of next week. Okay? So if you can't do 31 to 41, you toast. So get help. There are very few of you who can't write equations or write formulas. But there are a couple of you. There are little pockets in the room that messed up the crisscross. So if you're one of those little pockets, please come see me. I know some of you would rather not. If you don't want to see me, see someone, one of your friends who can do it well. Okay? A classmate from last semester, somebody. Okay? Does anyone have a question on something they got wrong that they want to ask me about? Second period asks lots of things. All of the math that's on this test, not on the very next test, which is on chemical equations. It's on the next test, which is stoichiometry. It's coming back around. So if you don't know how to do it, or you got it wrong, you need to get help with that. Okay? Because all of stoichiometry will be on one big test. You have approximately 4 to 5 every quarter. You already took 2. You'll have a benchmark. Y'all are third period, so you'll be first. Benchmark will be the 13th of March. Which is probably a Tuesday, because they usually don't do them on Mondays. So that will be the benchmark. And it will be all multiple choice. It's usually around 35, 36 questions. I make it, not the central office.
Do you believe that's the easiest test we took so far?
The one you just took is the easiest one we take in terms of content.
Boy.
Just being honest. It's the easiest we have in terms of content. Easiest content we do. The next test has more places for errors. Just pickier.
Okay, I got a question.
Okay. Ask.
So basically, like the test, you know,
Okay.
so, okay, let's say that you get, okay, like this one says potassium nitrate. So doesn't potassium have more than one? It doesn't. So any of this KN.
Depends. Which question, y'all?
I'm on 32.
32. All right. 32 says potassium nitride. Potassium only has one oxidation number. So when you look it up, K has +1. That's all it has. All right. Nitride means it's binary. It ends in IDE. Okay. It's not NO3 or NO2. Those would be 8s and 8s. Okay. IDE means it's just N. Has a -3 oxidation number. So we're going to bring the 1 down here and the 3 down here. So you get K3N.
Why do we have 3 again?
Why does what?
Add 3.
The -3? Because it ends in IDE. Okay? The one that ends in, for example, nitrite or nitrate, ITE and ATE are polyatomic. Okay? IDE is binary. Anything that ends in IDE is binary. Only one. That help? All right, what else?
24.
All right, 24 says what? Let me make test to look at. All right, so magnesium, and then CO3 is what? Did you use a Roman numeral?
Yeah.
All right, look up magnesium on your blue card.
I don't got one.
Hmm?
They only got one.
Yep. You probably looked up manganese, which is right below it, which has like 5 or 6. Okay, which would need a Roman number. But magnesium only has 1 and will not get a Roman number.
Wait, so what's he?
Huh?
What's he?
Magnesium carbonate. It will not get a Roman number. The very last one on that page.
Oh.
You use chromate. You looked up the wrong polyatomic ion. CO3 is carbonate. Okay, and I had a couple people mix up the polyatomic ion. Oxalate and chromate were mixed up a lot. I don't know if that one was right below it. Kathleen, 22. Look at verse 22 again. 22 should be aluminum iodate. IO3 is iodate. It should not have a Roman number because aluminum only has 1 oxidation number listed on the cards. There's no Roman number there. 21 is iron 3 oxide.
What about the 33?
33 should be tin 4 sulfide. All right, so 10 is SN. It has a 4 for an oxidation number. Sulfide has a 2, so you bring the 2 down and the 4 down, and you have SN2S4, right? Now, what do we learn to do when you have a 2 and a 4 in math class? Cancel out. So you end up reducing that to a 1 and that to a 2, so you have SNS2, like that. But that one, if you had SN2S4, did I only take off 1? I should have. Tomorrow. No, hydroxide would have parentheses. So Fe has a 3. Hydroxide is OH in parentheses because it's a polyatomic ion. It has a 1. 1 comes down, 3 comes down. You have to have the parentheses though, because what is outside of the parentheses? A 3. You can leave the parentheses off if that's a 1, but because that's a 3, the parentheses have to be there.
Okay, so on that other ones you did, where'd you get the 2?
Where'd I get what 2? Huh?
Or 1, 6, and 4, 4, 9. Where'd you get the 2?
Because sulfur has a -2 oxidation number. SNS, because it's last, it has to be the negative oxidation number on the card. So I had to pick the -2.
What can you do? 36.
Tell me what 36 says.
Oh, silver sulfide.
Same thing. Ag has a +1. Sulfide. S is second, so it has to be a negative oxidation number. So the negative oxidation number on the card is -2. So bring your 2 down, bring your 1 down. So you get Ag2S. Okay. Anybody else? Question?
38.
Tell me what it says.
Chromium 2.
Okay. Chromium has a 2. Phosphate has a 3, a -3. So put parentheses. 3 comes over here. 2 comes over here. So you have Cr with a 3, PO4, and then a 2. That 2 and that 3 cannot be reduced. You keep them where they're at.
How about number 41?
Tell me what it says.
Nitric acid.
That's one that you're supposed to learn. That's its formula.
Oh, damn. Listen,
You had HNO2, which would be nitrous acid. Anybody else? Anything you want to ask? No? Okay. Let me have my test papers back. Thank you, my dear. Somebody let Zoe and Darlene in before I forget them.
Adriana?
Adriana, sorry, Darlene Wheeler. Second. Whatever class. All right, so if you have makeup work to do, including quizzes, I'll be here for a little while on Thursday. Assuming they don't talk me into working Thursday too, but right now I'm only doing registration on Tuesday and Wednesday. So upcoming juniors are supposed. You're this week, I think. Wednesday and Thursday, maybe. I think it's Wednesday and Thursday. But I know Thursday. But I think you might be able to do a day early. I'm not sure. I know the juniors who are rising seniors, they're doing y'all in school with guidance. Y'all don't come at night. So y'all don't have to worry. But those of you who are rising juniors, you're supposed to come at night too. All right, you need a periodic table today. You don't need your blue sheet or anything else, just a periodic table. All right, for those of you who like titles, you can title it empirical formulas. I'm going to put this up. If you like two titles, it's empirical formulas and molecular formulas. It's on the whiteboard in red. Alright, so we're going to learn to calculate formulas today. And then tomorrow for the sort of mini lab, you're going to calculate and then use what you already know to write their names. All right, so an empirical formula is also referred to as the simplest formula. All right, it is a formula that cannot be reduced. Okay, it is already in lowest terms. So, to give you an example of this, if you have something like CaBr2, Ca has what subscript on it? And Br has what subscript? Can a 1 and a 2 be simplified? No, it is an empirical formula. Now, if you have something like you might have seen on the test, for example, like C2O4, if you had written a formula like that on the test, what would you have been expected to do? You would have been expected to reduce that into C1O2. All right, this here is the empirical formula, and this one would be what we'll talk about in a little while, and this would be the molecular formula. Okay? Now, sometimes a formula such as this throws people off, and they can't decide if that's the empirical formula or not. Is that the empirical formula? What do you think?
Yes.
I hear some yeses and I see some heads shaking. How do you decide? Because this is why I put this up here, because it throws people off. About half my class usually says yes and the other half says no. So how do we decide? What can be reduced? Okay.
But you can't reduce the one, but
That's the part we need to point out, okay? Several people are pointing out this right here. The S has what number on it? 1. Several people in second period, and I think Katie was getting ready to tell me that the SO4 has what around it? Parentheses. Regardless, the S has a 1 on it. In order to reduce, you have to be able to reduce how many subscripts? All of them. You can't select just the 2 and the 4. Given that all of them cannot reduce, you cannot reduce this formula. It is already in lowest terms. Okay? It is already in lowest terms. It cannot be reduced any lower than it is because of the S. So 2 of them were already empirical, and 1 of them had to be reduced to get to the empirical formula. Now, we're going to calculate empirical formulas today. We're not going to use oxidation numbers. We're not going to look up anything. We're going to use math to do this today. Okay? Have I given everybody enough time? Good call. All right. So here are our steps. All right. We're going to write empirical formulas today. Step 1, if we're given percents, we have to change it to grams. Now, some of our problems won't require step 1. Some of our problems will just be given in grams. If they are, we'll skip step 1. Most of our problems will be given in percents, though, and we'll have to do step 1. Okay? And we'll talk about how to do this. This step is really easy. Step 2, everybody knows how to do. Not a soul did this wrong on the test Friday. Okay? We might have messed up atoms. We might have messed up molecules or formula units, but everybody did grams to moles correctly on the test. Okay, so we're going to change grams to moles. Okay, now step 3 is kind of long and it sounds weird, but you know how in math class when you divide the left side of the equation by 3, what do you have to do to the right side? That's all I'm saying here. Okay, so if I divide the smallest number of moles by itself, what do I have to do to the other ones? I have to divide them by that same small number. So we're going to divide the smallest number of moles by itself and all the other numbers of moles by the smallest number. So if you have 2 numbers, you got to divide them all by that smallest number. If you have 3 numbers, you divide them all by that smallest number. Now, once you've done that, you'll be able to write the formula. All right, is everyone in time or do I need to wait? Don't see anybody. All right, so here's a sample. Okay? Now, we're going to do 3. I've picked something different in all 3 samples to try to make sure you have things that I might use on the quiz or the test to throw you off. So I would recommend writing down all 3 samples in this one, just in case you should see something like it on the test or the quiz. The first 2 in particular you need to write down. Look, this one's supposed to come out tomorrow. That's it until next Tuesday. I'll be depressed by then. All right, we had time to write down the question. All right, what's step 1 say? Well, how are we going to do that? How? How?
You get the opposite of when you get grams for that percent, so you multiply that.
Easier than that. What'd you say? Easier than that. What? Easier than that. What else? Huh? Yes. That's it. All right. So 32.38 grams of Na. 22.65 grams of sulfur. And 44.99 grams of oxygen. So why can I do that? What's the reasoning behind that? What do you suppose all those percentages add up to be? So if we have 100%, we're just going to assume this is how much in our sample. 100 grams. Instead of 100%, we got 100 grams. It's a 100-gram sample, so we're just going to change the percent to grams. That easy. Okay? So what do I do next? What's step 2 say? Change grams to moles. So what do I do to change grams to moles? Draw a little T-chart. All right, so little T-charts. What goes on the bottom? What goes on the top? What goes beside moles? What goes beside grams? Atomic mass. So 22.9, 32.0, and 16. I only know them to one decimal place, so that's all I used. And you can use whole numbers. It won't make any difference.
Significant digits.
Doesn't make any difference because you're not getting a numerical answer. I would recommend taking it out several decimal places just because there are a couple of these that I have that if you round too much, you're going to get the wrong whole number. Not that I'm trying to trick you or anything. All right, so we've done step 1. We've changed percents to grams, and we've gotten moles.
Ms. Wall,
Yes, ma'am.
can you send Derek Dearman to the office just for a moment?
I will.
Thanks.
Welcome. Take the best step. All right, so if we look at step 3, what does step 3 say to do? Divide by the smallest. So who is the smallest number up here? Okay, so we're going to divide by 0.7078. So 0.7078, and I get a 1. Now, the rest of that step says to do like you would in math class. If you divide by 3 on the left, you divide the other side by 3, right? So now we need to do what with those other numbers? Divide by the same thing. So 0.7078, 0.7078. Where's my calculator? All right, so 1.413 divided 0.7078, I get 1.996. What is 1.996? That's a 2. 2.811 divide 0.7078, and I get 3.97. What's 3.97? That's a 4. Now, the last step is to do what? Write the formula. All right, so Na has what subscript?
2.
S has what subscript?
1.
And O has what subscript?
4.
Questions?
It's like backwards.
What is it?
That's it.
Wait, do you still gotta add a 1?
No, I only did it for teaching purposes today. Any questions? Everybody with me?
Yeah.
Isn't that the example question you did?
Well, it's just one that I wrote to show you that it's an empirical formula. Now, if you get this answer and you try to reduce it, that should tell you you've done what? Something wrong. These questions are already in lowest terms, so you should not be able to reduce them. Okay? Everybody with me? Okay, let's try another one. Now, I have purposefully put something in here to trip you up. So write it down so we can talk about what I put in here to trip you up. And you will see this trick on the quiz and the test. All right, you got it ready? Yeah. All right, so what are we going to start with again? 26.56. And what do we do to it?
Grams.
Of? What symbol do I use? Okay. And 35.41 grams of CR. Good. And? Okay. Everybody good so far? Take the percents off and write G. So we're all good with those steps, right? So what do we do next? You know, there's like 22 people in here. I like to hear somebody besides my own voice. What do we do next, Jackie? Got to write the T-chart. So we're changing them to what? Changing them to the moles. All right, what goes on the bottom, Joanna? Okay, what am I putting on the top? All right, what goes beside the moles? Adriana. What do I put beside grams of K, Isabel? Okay, beside chromium, Juan. Who? Okay, and oxygen, Jonathan. It's like pulling teeth to get you people talking to me. All right, so 26.56 divided by 39.1, 0.679. 35.41 divided 52 is 0.680. And 38.03 divided 16 is 2.376 moles. All right, what do I do from there, Brooke?
Write the formula.
Not yet. You got another step yet.
The smallest one.
Okay, what's the smallest one?
6.79.
Okay, so I'm going to do what with that 0.679?
You're gonna
Remember what to do with it? Baby, and tell her what to do with that 0.679. Divide by. All right, so once I divide by that 0.679 and get a 1 here, what do I do with that, Lyric, from there? Divide the rest of them. All right, now, everybody can see that that's going to be a 1. I want you on your own calculator to divide this bottom one, because that's where the trick lies. Right there. So punch it in your calculator and see what you get. I know. Stop yelling. Just write it down. Give everybody a chance. Patience. How come y'all won't talk to me when I want you to, and when I don't want you to, y'all all yell out an answer. All right, so Luke, tell me what you got on your calculator.
3.5.
Okay, is that what you got on the calculator?
No.
What did it actually say?
3 point. I think it rounds up.
Yeah, it did. All right, you got 3.499 on the calculator. Now, when we need to use that, all right, what does 3.499 mean? What are we going to do with it? Are we going to round it to 4? We're going to round it down to 3? Can't do that. All right, it means 3.5. Now, when we were writing formulas last week, okay, big this. All right, we had K with a 1, right? We had CR with a 1. And then we got O with this 3.5. I'm pretty certain we didn't write any formulas that had half in them anywhere, correct?
Right.
Now, some of you would say round that half up to 4. Some of you would say round that half down to 3. Neither of which is correct. We cannot round a half off. So think math class. How do you get rid of a half in math class? And first of all, don't tell me you've never done it because you have. All right. How do you get rid of a half in math class? What?
Multiply by 2.
Yes, you multiply by the reciprocal. Very good, Jonathan. Yes, you did, and so did Jonathan, and Brooke yelled out his answer. K2, CR2, O7. Okay, the 2 is distributed through the formula. Okay, K2, CR2, O7. Anytime you have a half, okay, a half is written as 1 over 2, correct? 2 is in the denominator. So if you multiply by 2, 2 gets multiplied by 1, so you end up with 2 over 2. And what does 2 over 2 become? 1. That's why you multiply by the inverse or multiply by 2. So in chemistry class, you can do the same thing. But that 2 distributes to the subscripts. Okay? So it becomes K2, CR2, O7.
Could you write it either way?
What?
The answer.
What? K1, CR1, O3 and a half?
Yeah, and then put a 2 on the outside.
No. You better distribute if you want full credit. Okay? All right. Last example. All right. This time I gave you the data messed up. We got to figure out how to fix our data to be able to do this. And the question works normal, but I messed up the data and how I gave it to you. You got to straighten it out first.
We don't need the blue sheet.
Hmm?
We don't need the blue sheet.
Nope. All right. So what's different about this?
No percent.
It gives you the total
Okay, it gives you a total mass, okay, of what?
of phosphorus and all.
Okay, so you have 10.150 grams of what? Phosphorus and oxygen. All right, so what's this then?
It's oxygen.
Okay, so 5.717 grams of just oxygen. So in order to set up our questions like we did here, these were individual masses of the elements, right? These were individual masses of the elements. Did we have any of this combined mass crap? No. So we need individual masses of the elements. Well, whose individual mass do you have? So who else's individual mass do we need? We just need phosphorus. So what are you going to do? Exactly. Okay? So what's my mass of phosphorus? 4.433. All right. So if this is your mass of oxygen and this is your mass of phosphorus right there, solve my question. Set it up and find me the empirical formula of phosphorus and oxygen. Set up your two charts and solve. I better get the door because I'm not walking back there. Hey, Miss Smith, how are you? What's up?
Do you mind giving this to Valeria next period?
I don't mind at all. Be glad to do it.
We got a tournament on Saturday.
Oh, I'd be glad to fill it out, but I'm not a certified MD.
We can pretend. Oh, y'all, that's some.
Nah, they're doing a problem on the board.
Yeah, I'd have to sit back through a chemistry class before I remember how to do any of that.
They're gonna dazzle me with their skills the moment I'll yell out the right answer.
Is that the right answer?
What you got? Oh.
She says, oh, no.
All right, what's the rest of y'all have since Ava was shy?
No, don't say it.
P205.
I was gonna say, call out on Brooke.
All right, I heard some P205s and then I got a P207 over here. So let's talk about it. All right, and I suspect that P207 is a multiplying error. So if it is, you need to use a calculator on a quiz, not do that crap in your head.
Oh, no, it's just, I put 3.5.
All right, so we had a 1 and a 31. Yeah, I used whole number. 5.717 and what, 16 grams, 1 mole. All right, I don't need any more in my way. So I got 0.143, 5.717 divided 16.357, right? All right, who is the smallest out of those two? 0.143, so I get 1.143, the 0.357 divided 0.143, and I get 2.49. 2.49 is the same as what? 2.5. So when I write my formula, I have P10 2.5, and I do what with that? Multiply by 2. So you can have P2O5. Any questions? What, when I multiply here? Every time you have a half, okay? Every time you get this 0.5, the only way you can get rid of the half is to multiply by 2. Because the opposite or the reciprocal of a half is 2. So you're always going to multiply by half. Now, if this was an AP class, if you had something like a third, if you had something like 2.333, like let's just say we had 1 and 2.33, what would we multiply by? You'd multiply by 3. But you won't have that in here. Whoops.
So it's always going to be
It's always going to be a 2 in here. Okay? You'll either get a whole number or a 2 in here. Nope, I'm not. Okay? Now, let's talk about molecular formulas. All right, what is a molecular formula? A molecular formula tells the actual number of atoms. It may or may not be able to be reduced. Okay? Tells the actual number of atoms, and it may or may not be able to be reduced. So, if we have, for example, okay, if we have something like S2O4, we would know that S2O4 can be reduced into what? Okay, into SO2. We would know that this is the molecular formula and this is the empirical formula. Everybody knows that. We just practiced that a second ago when we were doing the introduction of empirical formulas. But suppose you have that same example or something very similar that we just talked about with something like KClO3. Can this be reduced? No, okay? This cannot be reduced. It is the molecular and the empirical formula. Okay, it's already in lowest terms. You can't do anything with it. So it is both the empirical and it's the molecular formula. Now, we want to learn to calculate the molecular formula. For some reason, students like the molecular formulas less, so they remember them less. When we do the benchmark in a few weeks, the vast majority of you will remember the empirical formula and do really well with that. The molecular formula, more of us will forget. I don't know why. It's easier, but people forget it. Is everybody caught up? All right. So, how are we going to do this? All right. First of all, we need 2 items to calculate the molecular formula. Number 1, you have to have a molar mass. Without, there's no calculation. All right, if you don't have the molar mass, you're dead in the water. You cannot calculate a molecular formula without the molar mass. Must be given. Number 2, you have to have the empirical formula. Or the info to find it.
Put TL instead of TW.
Where are you at?
Title.
Yep, you're right. Here. There you go. I didn't even catch it. Just use the number. Now, we're going to start easy, and we're going to have questions that the empirical formula is given, and we're going to build towards the ones where you have to find it, because on the lab sheet tomorrow, which ones do you think you have? The ones where you have to find it, okay? Because you're going to have to find it, calculate the molecular formula, and then you're going to have to name both, the empirical and the molecular formula, okay? So we have to tie in what you already know and what you're learning today. All right, so how do we do this? You're going to take the molar mass, fix that, that's given, okay? And you're going to divide it by the mass that you add up. Okay? So this will come from the empirical formula. Okay? And the molar mass is going to be given. The mass you add up is going to come from the empirical formula. Now, when you divide, you are going to get a whole number. A 1, 2, 3, 4, 5, 6, 7, 8. If you don't get a whole number, you have a mistake. Because that whole number is telling you what the formula was reduced by. Okay? And I'll explain that when we do the example. You're going to take this whole number and you're going to multiply it by the empirical formula. And you're going to be left with the molecular formula. So if the empirical formula was reduced by 2, you multiply the whole formula by 2, and you get the molecular formula. If it was reduced by 4, you multiply it by 4, and you get the empirical formula. And it will give you the molecular formula. Okay, the most common thing it's reduced by is a 2. Now, if we have this situation where the molecular and the empirical formula are the same, they're one and the same. Whoops, wrong way. What do you suppose the whole number is going to turn out to be? What? It's going to be a 1. Okay? So when you multiply it by 1, these two things are going to be the same. Okay? And you can get a 1 here. Happens all the time. All right, everybody got the steps? All right, let's try an easy question. All right, what is the molecular formula for a compound with a formula mass of 283.889 and a formula of P2O5? All right. Everybody had a chance to write down? So what are we going to do? Based on the steps we wrote down, where do we start? What do you think, Mackenzie? What does it say? Right here. Go back, board. What does it say put on top? That's what? So what molar mass is given? Okay, so I'm putting that on top. 283.889. Okay? And I'm putting what on the bottom? Whoops, wrong way, stupid. All right, what am I putting on the bottom? What I do what? Juan, what I add up, right? So what am I going to add up in this question? Of what? What's the only thing left I can add up? The only thing in the question I can add up. Derek, what's the only thing I can add up? That's all I got left. Okay? That's all I got. P2O5. I use this on top because that's my given mass. And I'm going to add this up. Okay? Everybody with me on the two things I gave you? So, how do I add it up? What do I do, Amara? Okay? How many O's? I'm going to use whole numbers. 31, 16, I get 62, I get 80, I get 142. All right, Diana, where do I put the 142? On the bottom. All right, what do I get when I divide that, Yesenia?
1.99.
All right, so 1.999 would be the same as a what? Okay, so if I divide that and I get 2, this means the original formula was reduced by a 2. Okay, that's what that number means. The original formula was reduced by a 2. Okay, so we're trying to find the original formula. So now I take this 2 and I multiply it by the empirical formula. What's my empirical formula, Zoe? Okay. So what do I get when I multiply?
P402.
That's my answer. Now, here's the most common mistake. People look at that answer on the quiz or the test and they go, dang, I need to do what to that answer? Exactly. They go, I need to simplify and reduce. Now, what was the point of the question? To find the what? The original formula. So if you simplify this, you did what? You just wiped out all of your work and go back to the original question. If that's a 20-point question on the quiz, I'm taking half. I'm taking 10 of the original 20 points that I just gave you for stupid, okay? Don't wipe out all of your work, okay? That says to me, if you do that and wipe that back out to P205, do you understand what you're being asked to do in the question? No, you have no idea what I'm asking you to do, which is why I'm taking half. Okay, I know those math teachers, they like to put a little -2 out here to the side because you did all the steps right. I'm into conceptual work. Do you understand what I'm asking you for? If you wipe out everything you just did, do you understand what I'm asking? You have no concept. Okay? So, find me the answer. You don't have to write it down. You already got one. Find me the answer. Then we're going to tie it together and build it together. Empirical and molecular combined. And if we got time left, let's just start on your homework. Find me an answer. All right, what do we get? Anybody not get a C6H6? Do I need to work it on the board?
Well, you said what?
C6H6? So you had 78.110. This had a mass of 13. So divided by 13 would be 6. So 6 multiplied by CH would be C6H6. Yes? No? Yes? All right. So this is what we're doing tomorrow. Okay? Now, tomorrow you cannot use your notes. Okay? You get a partner. Assuming everyone's an odd, even number in here. If there's an odd number, then somebody ought to do that. Okay? You cannot use your notes. You get a partner. Do a problem like this, and then you have to write the names of the empirical and the molecular formula. I give you a moment to write it down, and then we're going to work, and then we're going to practice some homework questions. Make sure we're all on the same page when you come in tomorrow. It is a lab break. All right, find me. Write it down if you want it. You don't have to write it if you don't want to. All right, then we're going to work it together. Make sure everybody can do this tomorrow. I want nothing but excellent grades tomorrow when I'm grading. Because I'm going to need to grade these fast after I get done with registration. Or on Thursday morning during first period. I said you don't have to if you don't want to. I'm going to work it. If you want to write it down, put it in your notes though. You will see these on one of these on the quiz Thursday as well as on the test. Okay, and remember, this will be after the next unit, so you'll need to have something to refer back to. So I might make sure I have it so you have something to refer back to also. Because it'll be a couple weeks before you see this on the test. What'd you say, Mackenzie? Okay. Oh, and next week, Zoe, Monday and Thursday would be the best days to do the test, if either of those days work for you. In case you work and need to, look at your schedule.
So you're not saying I have to do that?
Today I have to be like, media center right after school, today and tomorrow.
I thought they said the upcoming seniors had a certain day and everything.
I swear they said they were registering y'all individually.
They do, we got ideas.
That's what I thought. I'm pretty sure y'all don't have to do any of this after school stuff. I'm almost positive that y'all are being done individually. Don't have to bring anybody. I don't even know if the rising ninth graders are coming these 3 days. I thought it was more just 9th and 10th graders.
We just got into the high school.
22.
Wait, what's?
Rest of the next year.
All right, so if we look at this,
Who cares if it's after 19, is all I'm saying.
That was down for 2020. Okay, what is 2020?
moving on. All right, so if we look at this problem, do you have the 2 pieces of information you had in the last 2? What's missing? What formula? The empirical formula. Okay? You have molar mass. Okay, that's given. But you don't have the empirical formula. So what do you have to start with? You got to do the empirical formula. And this is what you'll have to do tomorrow on the lab. Okay? So you have to take the two percentages and do what with them first? Put them in grams. So 85.64 grams of C and 14.36 grams of H. All right, what are we doing from there? Convert to moles. A little T-chart. Look at that. I had a few people actually answer me that time.
Look at us prosper.
I know, there's some hope for y'all yet. All right, so what goes on the top
1.
and on the bottom?
The math.
Okay, so the mass of H is 1, carbon is 12, 14.36, 7.136. What are we doing now? Guy who's smaller?
7.136.
Well, let me see if I remember that number right from the last class. I think I did. Yeah. And I got 1, and then I got 2.01, which is the same as 2. All right, so what do I do with those two numbers?
C1H6.
All right, so C1, H, and that's the what? All right, so that's my empirical formula. All right. So there's my empirical formula. Now, I have to do the what?
The rest of it.
What's the rest of it called?
0.08 divided by.
Okay, so we're doing the molecular formula, which Zoe said I had to take the 42.08 and divide by something.
Empirical formula.
Okay, so how do I find the empirical formula mass? Okay, pull them out to the sides. How many C's do I have? How many H's do I have? The mass of carbon is 12. Hydrogen is 1. So I get 12, 2 for a total of 14. So where do I put that 14?
Underneath.
Okay, so 42 divided by 14 gives me a 3. So what does that mean?
It means that it was reduced by 3.
Okay, so what do I do with that 3? So 3 times CH2 is C3H6. And this right here is the molecular formula. Now, tomorrow when we do this, they will be compounds that are not organic compounds that you can write the name of. Okay, there are 5 of them. And then there's one bonus. Now, you need to find a sheet that I gave you last week. It looks like this.
Homework. Is that what we're gonna do?
This is what we're fixing to work on.
I don't like that kind of homework. I don't even. So many words.
I'm so sorry.
Sorry. What is it?
It looks like this. I gave it to you last week.
So we can use no notes tomorrow.
Nope. Only you and your partner.
See? For the what?
Just you and your partner. And I'm not picking your partner. You may pick who you want. All right, everybody found it? All right, we're doing under the problem column like usual, not applications, but the problem side. We're doing 10C, 14, 15, 16, 18B, 18C, and 19. Now, this is also the same stuff that's on your quiz on Thursday. If you can do those questions, you can do the quiz on Thursday. The problem side. Okay, same side we were on the last time.
So when you say 14, do the whole 14?
Yeah, it's only one question.
Oh.
Yeah, there's no ABCD. Just take questions. Okay, everybody got the questions? Anybody not have the worksheet? I made a couple spares for somebody in the second period in case y'all couldn't find your stuff. This paper just flew across the floor. Anybody need the paper back? He's always collecting it off the floors of his feet. I'm guessing Fabian or Brooke based on the way it floated across the floor. Fabian?
Really?
All right, everybody got it?
Yeah.
Okay. That's what we're working on. I'll tell you when you can turn your